Okay. Any question about the homework or the discussion 10? Okay. Today is still it's about common interval. And we are use the hypothesis and use hypothesis to find the common interval. Yeah. And like in question 1, they ask you to find the UMP test first. Then you can use this. You can find a access region and use the access region to find the UMA common interval. Yeah. And the second two is like this one is we have the pivotal quantity. So in this case, when the distribution is exponential theta and theta, you will have the two different pivotal quantity. So you can control the two different common level, and we want to figure out which one is better. And next one is they call it a cost paradox. It's the same, just find the rejection region first, the set region first, and then use the set region to find the common level. Okay. And please start to do question 1 to 3. And if you need any help, please let me know. Nando. Okay, let's go through the questions. So for the question 1A, we want to find UMP test. Okay. With this form. Okay, so the first step we want to do is we want to find this. So like the rule is the h equal to theta little, the alternative is h equal to theta 1, and the theta 1 should be smaller than theta little. Okay. So the step 1.
Can't we use the Carlin-Rubin theorem?
Oh, okay. The color Ruby series for for this case, it's in this case, and you have to. I think if you can show this is a monotone likelihood ratio, then you can use color Ruby series.
Which it is, right?
Yes.
It is.
Yeah, it's, so you have to show this first. Okay.
It's monotone in the sample mean.
Yeah. Yeah, that's a way to do that. But actually, for this type of the hypothesis, you don't need to use the monotone likelihood ratio. Yeah.
Would we get the same results if we did that?
Yeah, we will consider. So usually the original this one is this case. And this case can be the first state is this, the second state is generalized to this form. And then you use the likelihood ratio to generalize to the alternative, and the rule is have this form. And this series is Kali-Ruby series, and this is Never Pearson lemma. And this one, I see they don't have a name, and we don't have a series in the nature, but it's not too hard. So, okay. Yeah, if you find a UMP10 in this case, it will also be a UMP10 in this case. Yeah, because the rule is smaller, so it still will be the size alpha test. Okay. Okay, so here we will use a name Pierce lemma. Then what we want to do is the rejection region should be 1 and little, and here is the f1 greater than constant f little, and it's on the auto case. Okay. Okay, then we want to find c. So okay. Let's say look at this. F1x is the product of the density, so it be theta little to yeah, it's exponential. Theta power n exponential summation xi Okay, like this. Now generate some constant theta 1 to this. Okay, 1. And this is equal to theta 0, theta 1 to power n. Then you greater than some constant and the exponential of the negative this and theta 1, theta 1, 0 minus theta 1. Okay. Okay, let's move this constant to here. Okay, and this term is the theta 1 is smaller, so it's negative. Yeah, theta 1 is smaller. Yeah, it's negative. So this is an inclusive function in S bar. So it's equivalent to find the S bar is smaller than some constant C star. Okay. Okay. Then you can define the C star as the. Then we can find C star. Yeah. So the C star should be the. This must be equal to alpha. So it should be. How about summation of Si? The summation of Si is follow the gamma distribution with the degree of n and theta 0. Okay, so the C star should be the we can define as Gn alpha, which is the alpha's quantile of the gamma. Okay. Okay, here I use this. Okay.
Sorry to interrupt. I think your screen stopped updating.
Oh, sorry. Okay. Yeah, thank you for telling me. Okay. Okay. So first we realize the phrase. Okay. So first we realize this is negative, so it's an increasing function of the summation xi. And I see here I change to the divided by the sigma this sigma, then it can be 1. This okay. Yeah. So this is negative, that's right. Okay, I think this equal less. Okay, and we will reject if the value is too small. It's not true. I think it's weird. It should be too. It should be large. it should be large. So minus alpha quantile. And F1 here, F2 here. So I change this to here. This is here. So it's theta 0 minus theta 1. This is negative because theta 1 is smaller. Yes, theta 1 is smaller. So this is positive. So this is inclusive function. Okay, that's weird. Oh, it's the same. Okay, it's nice. Okay, so this should be alpha's quantile. Okay. Okay, and then you realize the rejection region is independent to the theta 1. So you can join us to the test. To okay, like this. Okay.
So I think we are not able to see what you're writing.
Right? Why? Oh,
I don't know why it's not working.
let me share. Let me do this again. Okay, it's pretty weird. Okay, so so the key is we define the rejection region with the Kali Ruby with a name PS lemma, and you realize the rejection region is independent to the theta 1. So that means we can join us to when the alternatives look like this. Okay, so that is a UMP test.
Is there any clue that lets you think when you can use this sort of trick in general?
I think you mean why I can do this? Okay.
Yeah, how did you know that you could start with Neyman Pearson that in principle applies to a different situation?
Okay. This is a standard way to do that. And I think there's a theory in the textbook and they put the theory with this step. I just follow their philosophy, yeah. So this is standard way to control a UMP test. So we usually only know the UMP test look at this. Oh, it's start update. Start update again. Usually we only know how to control US test for the in a simplest case, like in a simple test. Okay. See, use the 9 will be much more stable. Okay, see this another way. So, did I change the? If we go to see the proof of a quasi-Rubik theory, they will use the same technique.
Okay, so
Yeah.
is it
That's a good
possible that so is it possible that you start with Neyman Pearson and then you realize that you cannot make the generalization at the end? Is that possible?
Yeah. Yeah, typically the rejection rate only depend on the rule statistic, the null hypothesis, and
Okay, yeah.
yeah. So it will independent to the alternative. Then you can join that to this case. Yeah. But the name piece only tell you in a simple case, now what is the UMP test. Okay, I just open my iPad. Yeah. So please wait a moment. And I think the second part is easy. Just when you got a set region, then you can define the hypothesis. Define a common interval. Okay, nice. Okay. Why? Okay. Yeah, hopefully it will be stable now. So, okay. Yeah, so here we want to find the inverse of the set region. So in B, first we will have the accept region like this, which is we know that the S bar should be no summation of xi. That should be smaller than the Gn alpha. And this is the rejection region, so it should greater than Gn alpha. Divided by theta 0, okay. So the counter interval will be the theta mark below to the here. So change this to theta. Okay. So this notation is confusing, just like the So this is theta. So just like this, okay. But here we collect the x. Here we collect the theta. Yeah. So it will be theta smaller than this.
Yeah, it's not working, I think.
Okay. How about you guys do question 2 and 3 first, and I'll try to figure it out. Yeah. Yes, it is the same.
Is this in number 2 the 2-parameter exponential distribution?
Which one?
In number 2.
Number 2, you mean 2 distribution? Can you say it again?
The distribution, it's the exponential, but with 2 parameters. Is that right?
Yeah, it's exponential. It's exponential. So the first theta is the sheep
Okay.
amount. Yeah. So you have start from theta to infinity.
Okay.
I know how to do. I can use let me leave the room.